Hi everybody, so today we have to complete a lab in class. We are going to be calculating our heart rates. And so like we learned last class, we can calculate our heart rates by calculating our pulse. We can do that because our pulse rate is the beating of our artery. And when our artery beats, this matches the beating of our heart rate. So let's take a look at the background and explore blood pressure first. So blood pressure and heart rate are a little bit different. So blood pressure refers to the amount of pressure that the blood flowing through your arteries is exerting on the artery walls. And so when you have blood pressure, there are two different measurements. The first one is systolic blood pressure. This indicates how much pressure your blood is exerting against your artery walls when the heart beats. The second number is called diastolic blood pressure. This is an indicator of how much pressure your blood is exerting against your artery walls while the heart is resting between beats. Typically, the first number, the systolic blood pressure, is more important as it is a major risk factor for cardiovascular disease for people over 50. For most people, systolic blood pressure rises steadily with age due to the increasing stiffness of large arteries, long-term buildup of plaque, and an increased incidence of cardiac and vascular disease. So remember when we were learning about the structure of arteries, they have a thick band of smooth muscle in there. And it needed to be smooth in order so that it can be flexible and strong, so that it can expand during systolic when the blood is pumping blood, and then contract again during diastolic beating. Long-term plaque is usually caused by unhealthy eating, things such as smoking, and these essentially block up the artery so that blood cannot flow as freely and smoothly. So how is blood pressure measured? It's usually measured in millimeters of mercury. A typical blood pressure of a healthy person is 120 over 80 millimeters Hg, or just 120 over 80. So that, again, the first number represents the pressure when the heart contracts and is called the systolic blood pressure, and the second number represents the pressure when the heart relaxes and is called the diastolic blood pressure. Part C. Understanding the difference between blood pressure and pulse. While your blood pressure is the force of your blood moving through your blood vessels, your heart rate is the number of times your heart beats per minute. They are two completely separate measurements and indicators of health. For people with high blood pressure, there's no substitute for measuring blood pressure. Heart rate and blood pressure do not necessarily increase at the same rate. A rising heart rate does not cause your blood pressure to increase at the same rate. Even though your heart is beating more times a minute, healthy blood vessels may dilate, which means getting larger, to allow more blood flow, to allow blood to flow more easily. So remember, again, this is why the arteries have a structure that allow for a lot of flexibility because they're constantly dilating and then contracting. When you exercise, your heart speeds up more so blood can reach your muscles. It may be possible for your heart rate to double safely, while your blood pressure may respond by only increasing a small amount. All right, so let's look at procedures for the first part of the lab. We are going to measure our pulse. You should know that your pulse refers to both the physical thump created in your arteries by the contraction of your heart muscles and the number of these thumps your heart causes per minute. So that's right. Remember, rates are the amount of time something occurs per time. So when we're talking about pulse, the time is always per minute. So we have several pulse points along our body. These places are where arteries come close to our skin and we can feel them readily. So we'll be listening to two of them. The first one are called the carotid arteries. This is located on our neck, And the second one is the radial arteries located on our wrist. So to measure your pulse using your carotid artery, you're going to find it by placing your index and middle fingers to feel around in the groove of your jaw just below your neck. You can feel on either side of your windpipe, and you should feel a slight pulse. So to measure your pulse rate of your carotid artery, count the number of pulses in 60 seconds. Record your carotid artery pulse rate on the write-up sheet. Next, you're going to measure your pulse rate using your radial artery. To find your radial artery, hold one hand straight out with your elbow bent, palm relaxed and faced up. Raise your thumb slightly skyward, as if holding an apple or a tennis ball, to create a small pocket under your thumb at the top of your wrist, where you will place the tips of your index and middle finger. Oh, I forgot one important thing. We don't want to use our thumbs for measuring the pulse of either artery, because the thumb has a pulse itself, so this could cause confusion while counting pulses. And again, you're going to count the number of beats at your radial artery for 16 seconds and record your artery pulse rate on the write-up sheet. So for both pulse rates, the radial and carotid, you're going to measure your pulse rate for 60 seconds 5 times, and then you're going to take the average and record them. Remember, to take the average, you're going to add up the beats from tests 1, 2, 3, 4, 5, and then you're going to divide that sum by 5 in order to calculate your average, right? So to calculate an average of two numbers, say 15 and 15, you would add 15 plus 15 is 30. You would divide that by 2, and the average is 15. And then you'll complete a few analysis questions. You're asked to define systole and diastole. Which measurement is more important and how come? Why do we not want to use our thumbs to measure pulse rates? And this is just analyzing your data. Did you notice a difference in pulse rate when measuring from your radial versus the carotid artery? If so, why do you think so? So that was just part 1 of the lab. So now that you know how to find your pulse rate, the next question is, how does the heart rate change based on body activity? So for instance, do you expect your heart to start working much harder and faster when you're running and jogging and doing intense physical activity versus just sitting, hanging out, and watching TV? So you'll record your hypothesis first, and then we'll continue on to the procedures. So pre-lab procedures require you to sit still for 60 seconds. You'll find your pulse either on your neck or your wrist, and you're going to time yourself for 15 seconds and take your pulse. Record your data. Repeat this 2 times so that you can take an average for 3 numbers. And so since pulse rate is always out of 60 seconds, you guys are going to be multiplying the number of beats or the number of pulses that you record in the 15 seconds by 4, because 15 times 4 equals 60. So this will give you your heart rate for 60 seconds. And this is going to be recorded as your baseline heart rate. So you're going to sit still for 60 seconds, find your pulse rate, time yourself for 15 seconds, take your pulse, repeat this 2 more times. Then you're going to multiply each of those numbers by 4. And then you're going to calculate your averages from those 3 numbers. And this will be your baseline. So after you have your baseline pulse rate, you're basically going to be doing this over and over again for different activities. So first you're going to be lying down on the floor for 60 seconds. Then while still laying down, record your pulse for 15 seconds. You're going to multiply the number of beats in 15 seconds by 4, and you're going to record your data. Then you'll stand up, walk casually, briskly, jog in place, jumping jacks, and dancing. And here's your data table below. So if you want, you can just start off by recording the pulse rates for 15 seconds for all of them, and then multiplying by 4 to get your pulse rate in 60 seconds. After you've recorded all of your data, and then you'll write it as a rate. So you'll do your pulses over a minute in the last column. And then there's one last question for the conclusion. Which activity was your pulse rate the highest? Does an increase in physical activity cause your pulse rate to increase? And can you accept or reject your hypothesis? All right, guys, have fun.